Hello! Today we are now going to do A-Level Mathematics Chapter 3, Coordinate Geometry. The textbook I'm using is by Linsky, Nicholson and Weston and is made by the Oxford University Press. Don't forget, it's from the Cambridge exam. Remember which syllabus you are taking, because in your exam, you will never know which questions come out. So it's good to know the syllabus. But don't forget, in coordinate geometry, you have your very handy tool, Desmos. Desmos is actually a very interesting interface to work with, and there'll be some Desmos interactives in the description. You can also play around with them to understand the topics. Well, if you are not content with Desmos, you can also make interactives in your software of choice. It includes GeoGebra or Mathematica or whatever simulation you like, whichever you're most familiar with, okay? We'll start with a recap. Some topics we have already learned in O-level mathematics or EMATS for people taking IGCSE. The midpoint of x1, y1, x2, y2 is x1 plus x2 over 2, y1 plus y2 over 2. The gradient of x1, y1, x2, y2 is y2 minus y1 over x2 minus x1. The length of x1, y1, and x2, y2 equals to the square root of x2 minus x1 squared plus y2 minus y1 squared. The first one is basically the midpoints of both points, so therefore it's the midpoint of the line. The gradient is basically rise over run, and the length is based off the Pythagorean theorem. So our next topics for recap are parallel lines have the same gradient. It's obvious because if you have lines which are on a different gradient, they are not parallel. Remember, parallel lines must always have the same direction. And here's a joke about parallel lines. Drum roll, please. And so much in common. It's a shame they'll never meet. And don't forget, perpendicular lines have the property when the two grades are m on n, n is negative 1 over m. This may take a little bit of work to verify, but you can use Desmos to do it. Let's talk about the equation of a line. Now, everyone knows the equation of a line. Y equals to mx plus c. But it's only when you know m, the gradient, and c, the y-intercept. This is the most specific type of equation where you're given the most amount of information. But coordinate geometry is not like this. And I repeat, not. It's not like this. Coordinate geometry involves points, but gradient and y-intercept are operations on points. Great. So y minus y1 is mx minus x1 when you're given a point x1, y1, and the gradient m. That's better. Now we have a point. But what if you're given 2 points with no gradient and no y-intercept? Now you may think you're broke right now, but fear not. Y minus y1 over x minus x1 is y2 minus y1 over x2 minus x1. Because y minus y1 over x minus x1 is always constant, because it always passes through y1 and x1. Understand? Okay, let's move on. So basically, here's a table for you to convert to the other alien forms. It might be alien to you, to the normal form y equals to mx plus c. There. You're done now? Oh, by the way, I have a program on Desmos called Linear Workshop, which is basically a free plot using y is mx plus c and a plot from points. So have fun using it. Let's talk about circles. Whee! X squared plus y squared equals to r squared is the Pythagorean theorem. Well, let me tell you, I don't think the Pythagorean theorem sounds nice. Probably like reverse shortcut distances formula, which sounds a lot more groovy and describes the purpose of the formula. Some how like differentiation and integration get their own notations, which I feel, in my opinion, are derived excellently. But Pythagorean theorem? Nah. So tracing all right triangles with radius r simply gives a circle. And you learn trigonometry, basically you can see a unit circle. These are all the right triangles with radius 1. So a circle on point A, B, and radius R. This one's using round transformations. You get x minus a squared plus y minus b squared equals to r squared. And you expand this, you have this. Ain't that nice? Keep in mind there's no xy term, and x squared and y squared are both 1. This is what happens when you see a circle. Well, and by the way, I also have another program in Desmos called Circles Workshop, which is basically some circles. Intersections time. When a line touches a curve at any one point, it is called a tangent. Well, let me give you another joke. Why did the coordinate geometry teacher was hated by the students? Why was the coordinate geometry teacher hated by his students? Because he often went on a tangent! I hope you had enough jokes for one video, but this is gonna get more corny. Sorry, wrong side. A tangent can be found by substituting the y of one curve into the other curve and solving for x. Yeah, right, x marks the spot, that's why it's called x. Told you it's another joke. Other variables besides x, use the discriminant to find set of values with two intersections greater than 0, one intersection is 0, or no intersections less than 0. Don't forget to read the question properly. I often underline the important part of the question. And obviously, the question is read the question properly, which is all important, so I underline the whole thing using a red line. Thank you, and see you in my next A-level mathematics video.